All right, how's it going, everybody? Today we are going to continue talking about polynomial functions. And so, as you can see, one of the things that we're going to do now is we are going to divide. So, let's get our notes ready to go. Let's begin. So, we're going to be using long division to divide our polynomials. And looking at this throwback question from back in your elementary days, if we wanted to divide 136 by 7, well, then we would bust a little casita method, right? We would throw the 136 right here. Our 7 would be out here. That's our divisor there. And so the first question we would ask ourselves is, how many times does 7 go into 1? Well, it doesn't go into 1. So then we ask, well, how many times does 7 go into 13? Well, it would only go in one time. And so what we would do back then was we would multiply our number 1 times 7. So I get a 7. And then the next step after that was, as soon as we had that number down there, we would subtract. So we do a little subtraction here. 13 take away 7, we end up with a 6. So I bring down the other 6, of course. And then the question became, all right, well now, how many times does 7 go into that 66? Well, 6 times 9 is 63. So we multiply the 9 times the 7. We get a 63. Of course, we're going to subtract. That's always the next step. And when we do the subtraction, we actually notice that we have a little remainder, a remainder of 3. Now, back in the day, right, in elementary, we used to say, all right, so my answer would be 19 remainder 3. Or put like an R for remainder. But then as we got a little bit older, we realized, and they teach us that my answer can also be written as 19, and my remainder was 3 out of, don't forget, we were dividing by 7, out of 7. And this is what our answer started to look like. As we got a little older and we understood numbers a little bit better, we started writing our remainders like this. So now you're in Algebra 2 here. Things are going to get a little more complicated when we're talking about long division of polynomials now. We're still going to bring in this fact where whatever I put on top, I multiply. And then whenever I write down here, I'm going to be subtracting. I'm still going to follow those basic rules from elementary. And I'm also going to bring in this concept of a fraction anytime I have a remainder. So let's get started. So when it says let's apply long division to polynomials, there's one thing we have to make sure that we're aware of and that we know, and that is this. A couple things. We have the room here, all right? Things that you should know and do. Make sure it's in descending order. So make sure both polynomials are in descending order. So look, for instance, if I look at this one, the biggest power I see is 4. So I see a power of 4, 3, 2, 1, 0, because there's no x. Perfect order. When I look at this one, yeah, that has a power of 1. Power of 1, power of 0. This is also in descending order. But our little note that we're going to add there is when you're writing in descending order, if a term is missing, so if a term is missing, use 0 as a placeholder. Now, that didn't happen on example number 1 here. We don't see that happening here. So when we get to it, we'll point out that note. So we're going to write it in there just for now. So if a term is missing, we're going to use 0 as a placeholder. Again, it didn't come up on example number 1, so we won't worry about it yet. Okay, so we're going to go with old school long division. So I'm going to write my 2x minus 1 out here. And then here comes that little casita or division symbol. And we go 14x to the 4 minus 5x to the 3rd minus 11x squared minus 11x plus the 8. Right? Long problems, but that's all right. Look, we're in Algebra 2 at this point. Now, the easiest way for me to explain this is we're going to play the matching game. My goal when I'm dividing, I need to match my first term with my first term. I want a perfect match. Yes, there's a -1 back there. I'll distribute. Remember, we have to do some multiplication eventually. So I'll distribute later on, but that's the first thing we want to work with. All right, so here we go. Using multiplication, I want to turn a 2x into a 14x to the fourth. So first of all, 2 times what is going to give me a 14? Well, 2 times 7. Notice where I'm going to write the 7. I'm writing it over here. I already have a single x, but I want 4 of them. Well, then I need 3. As you can see, I also use something that I like to call the lineup. I want to make sure that all my variables are lined up. So even though I'm trying to match these two, I'm writing it over here for this lineup. Again, there's a purpose for that. All right, here we go. So we're going to do a little multiplication with that green 7x to the third. Don't forget, I'm not just multiplying here. Let's get that one out of the way. 7 times 2 is 14. X to the third times x is x to the fourth. There it is. We have our first perfect match. But don't forget, I am also going to multiply with that -1. And that's something we never did over here, of course, back in elementary. We always had just one value. Well, here it's a binomial. We have to multiply twice. It's like doing this. 7x to the third times 2x minus 1. That's what we're doing. We're doing a little distribution. That's 14x to the 4, and then minus 7x to the third. So this times -1, -7x to the third. See how everything is lining up? Look at all my variables lining up there. And if you're thinking, yeah, but these didn't match, that was never our goal. Our goal was that these two matched up with each other. Okay. Back in our elementary days, I did my multiplication, and then I needed to subtract everything. Well, I'm not just subtracting one thing. I am going to subtract both of these. So I'm going to bring in a little parentheses there to help guide me with that subtraction there that we're going to do. So I'm going to distribute a negative because that also helps. So when I distribute that negative, I'm going to distribute it here. So it's a minus sign there, and it becomes a plus sign right here. There, the distribution of that negative has taken place. So I can now call it a plus sign for now. All right, got a little messy. It'll be a little more organized on the next one. So 14x to the fourth minus 14x to the fourth, that's why we needed a perfect match. We wanted these to disappear. But a -5, and a positive 7x to the third, we're now looking at 2x to the third. And remember, when we did this problem up here, we brought down the 6 afterwards. Well, here, I'm not bringing everybody down yet. I have to bring one term down at a time. So there, we brought down the 11x squared. Now the process begins all over. It's not like I have to do something new. I have to match. Remember, it's all about matching. I'm going to match that 2x, but now I'm going to match it with this one. Whatever's in front should get matched with whatever's in front. So that's what we're going to do here. All right, so now let's think. I want it to say a 2. Well, it already does, so I don't need a number. I want it to have 3 x's. I only have 1 up here, which means all I need is an x squared. I don't need a number. The number's already perfect. All I needed was 2 x's, and look at that. Everything is lining up. It's time to multiply, so here comes those arrows again. I'm just not going to draw them anymore, but I'm multiplying x squared times 2x. X squared times 2x is 2x to the third. Look at that. That's why I like lining everything up. I know everybody here should have a power of 3. X squared times -1. Well, that's negative x squared. Look at that. Everything here should have an x squared. So I'm ready. Look at that, a perfect match. That's what I wanted. Do I want a perfect match here? Not at all. This is the one that matters. So I'm going to do my subtraction. Don't forget, subtracting just really means this. I'm actually going to distribute a negative. I'll distribute the negative, so now it's a plus. There, the distribution took care of all my signs in here. And look at that, just like I wanted. This thing is officially gone. That's why we wanted that perfect match. And when I'm looking here, -11 and +1, We're looking at a negative 10x squared. All right, I'm done with that. So what do? I bring down the next term. Just remember, I don't care about this one. I'm matching my first term here with my new first term over here. Now this is my goal. It's all about matching using multiplication. All right, so I'll keep it going here. I already have a 2, but I want a negative 10. Well, 2 times what is going to give me a negative 10? Then it's a negative 5. Let's talk about x's. I want to have 2 of them, but I already have 1. Then I only need 1. So you see, this is why the lineup helps me. I already knew I was only going to have 1 x here because everything is lining up 2. I already knew this was going to have an x. And using that lineup concept, I can already see that last number not going to have an x at all. All right, let's start multiplying. Negative 5x times 2x is negative 10x squared. Look at that, the perfect match we were looking for. Negative 5x times negative 1 is positive 5x. All right, and of course, as always, it is time for me to subtract this bottom value, but officially that means I'm going to distribute a negative, so this becomes positive. This one over here actually becomes a negative for us. So it gets a little messy, but there, the distribution changed all my signs, and here's what I wanted. I wanted this one to go away, which is why we did a perfect match. But now negative 11 and negative 5 is negative 16x. And finally, look at that, we bring down the very last term. This is why I know this is my last step. I'm not going to have any steps after this. Last number I'm bringing down. So who am I trying to match now? I'm matching that 2x as always, but now I'm just trying to turn it into a negative 16x, and it has to be a perfect match. So 2 times what is going to give me that negative 16? Well, 2 times, let's see, 2 times negative 8. Not because it's an 8 here. 2 times negative 8 is going to give me that negative 16. Do I need an x? No, it's already there. Besides, look at my lineup. I know I don't need letters here. That's why the lineup is also good. Negative 8 times 2x is negative 16x. There's the perfect match we're looking for. And negative 8 times negative 1 is positive 8. Just a coincidence that it matched, but we'll take it. So here we go. We're going to do our last subtraction that we're supposed to do. Don't forget a subtraction. When I distribute that subtraction, this becomes a positive. That becomes a negative. All right. Gone. That's why we wanted a perfect match. But then when you look at this one, 8 minus 8, my answer is 0. Now remember, when we did this one over here and I ended up with a 3 at the bottom, I said, hey, I have a remainder. Well, if it's a 0, then I have no remainder. So that's perfect. So here is my answer. The answer to the division of these two polynomials is, look at that, way up here. I'm just going to copy everything I have on the top. 7x to the third plus x squared minus 5x minus 8. Just like that, no remainder. There's my answer. Again, we're doing long division. We're going to do a few more because I know this is new to us. But it's a lot of matching. And we're trying to match it up perfectly so that they cancel out later on. But it has to be a perfect match first. Let's try it again. Let's look at number 2 here. All right, let's make sure it's in order. I see a power of 4. I see a power of, notice, we're missing something. I'm supposed to have a power of 3. But anyways, power of 4. Power of 3 is missing. Power of 2, 1, 0. It's in descending order, but we're missing the x to the third. So we'll address that later. Let me look over here. Power of 2, power of 1, power of 0. This one's perfect. It's not missing anybody. And remember, if you're thinking, yeah, but this one doesn't have an x cubed either. Yeah, that's not what we said. If this one starts with a 2, then I should have a 2, 1, 0. 3 terms, we're good. So here's how we address that missing value, that missing term, sorry. So I'm going to write down my divisor here. X squared minus x plus 1. Here comes the little casita method here. And I'm going to write in x to the 4th, but here's the one that was missing. Remember, we didn't have that x to the 3rd. So we're going to put a placeholder. We set it 0, x to the 3rd, because there is no x to the 3rd. So if it's missing, we need to leave a spot for it. And then I'll write the rest. Plus 2x squared minus x plus 5. If it's missing a term, you have to put a 0 just as a placeholder, because remember, we want everything to line up. Now, yes, we have more values here. Doesn't matter. We already know it's all about matching. And my goal is to match everybody to this. X squared is going to match up to the first term over here. And that's my first one. Well, notice there's no number to worry about. And if there's no number to worry about, this one has 2 x's. I need 4 of them total. Then the only thing I need to multiply x squared by is another x squared, because x squared times x squared, that's what gives me x to the 4th. You're supposed to add your powers. So since I need an x squared, look at where we're going to write it. I'm going to write it right on top of this x squared. Notice how I'm starting 3 spaces over. Well, it makes sense. I have 3 terms. I should be starting 3 spaces over. I want all my values, all my variables to line up. Now, we're not going to multiply just here, which by the way is x to the 4. We're also going to multiply here. So a positive times a negative is a negative. X squared and x, there it is. Look at that lineup. X to the 3rd. And then we do have one more. This is a multiplication 3 times. X squared times 1 is just x squared. Look at that lineup. That's what we want. Now, subtraction as always. Subtraction is next. Don't forget, some people like to leave it like this, and that's okay, but sometimes people make errors. Be careful. When it says 4x, x to the 4 minus x to the 4, gone. That was the whole point. This is why we like to distribute instead. The mistake people will make is they go, oh, 0 and -1 is -1. That's why you have to remember. You have to distribute that negative. That was a negative. That's why I canceled. Negative times negative, positive. Negative times positive, now it becomes a negative. Distribute that minus to avoid mistakes. So what's 0 plus 1? 1x to the 3rd. 2 minus 1, 1x squared. So you're lining it up. And now I finally get to bring down my next term. All right, the goal here is matching. I want to match this with this now. That's what I'm trying to match. This one has 3 x's. This one only has 2. Well, then all I need is just 1 more x. Besides, I knew it was going to be an x. Look at that. It's all lined up. All right, here comes my multiplication. X times x squared is x to the 3rd. There's the perfect match. X times negative x is negative. X squared right there. And x times 1 is x. Now, don't start canceling anything yet. I know you can see some of those. Just wait, because don't forget, you're supposed to subtract all those blue ones right here. Subtracting means this positive is now a negative. This negative is now a positive. This positive is now a negative. There's the distribution, and there's what we wanted. A positive x to the 3rd and a negative x to the 3rd go away. 1 plus 1, you see, they didn't cancel. 1 plus 1 is now 2x squared. Negative x and negative x, they don't cancel. Now it's negative 2x. And look, now we know this is going to be our last time we do this. Why? Because that number 5 is coming down. It's the last thing I have left. All right, so here we go. My goal is to match this x squared and turn it into this. Well, if you notice, the first thing I need is I need that number 2. So I'm going to bring in a number 2. Let me put that up there. And do I need x's? No, I have 2 of them here. I already have 2 here. And I already knew I wasn't going to need letters here because of my lineup. All right, let's multiply. 2 times x squared is 2x squared. There's the perfect match. 2 times negative x is negative 2x. And 2 times 1 is 2. Again, if you're worried about these not matching or this one not matching, that's not what matters. This is the one we wanted to match up. That was our goal. All right, here comes that subtraction again. We're going to subtract. But subtracting just means I'm going to change all my signs. There's a negative. That becomes positive. This is now a negative. There, my distribution has taken place. And now we're ready. 2 and negative 2, gone. Negative 2 and positive 2, hey, also gone. That's great. But 5 and a negative 2, I actually have a 3 left over. So notice, we actually have a remainder. So let's talk about how we're going to write our answer. Now remember, my answer's up here. There's my answer. That's my quotient for the most part. So look at how we write our answer. Our answer is x squared plus x plus 2. Again, I'm just copying what's on top. But here comes my remainder. We say plus, and my remainder is 3. The question is, what did I divide by? Well, I was dividing by everything up here. I was dividing by x squared minus the x plus the 1. That's how we write our remainders. Whatever we have left over, we write it on top of a fraction, and then we write our divisor here right at the bottom. All of that right there is my answer. Okay. Now we have a few more to practice here just to get you ready for this. Again, this is one of our newer concepts in Algebra 2. So let's keep it going. We just need you to get the hang of it. All right. So here's number 3. Now for number 3, let's make sure everything is in order and let's see if there's anything missing. Power of 4, 3, 2. I see. We're missing that x squared. You might say, oh, it's over there. Yeah, that's something else. In this one, I'm missing an x squared. Power of 4, 3, 2, 1, 0. All right, we're good there. This one starts with a power of 2. Power of 2, 1, 0. This one doesn't need anything. This one's fine. All right, let's set it up. 3x plus 2. Sorry, I forgot the x squared completely. There we go. So x squared plus 3x plus 2. Here comes our little dividing box. And then here comes the 2x to the 4th, the 3x to the 3rd. But like we said, we were missing a value. So I'm going to bring in a 0 x squared. That's just kind of holding a spot. Plus 5x minus 1. All right, we're ready to go. It's all about matching. I'm matching this with my first term. So right off the bat, I notice I need a number 2. All right, I need a number 2. Oh, by the way, look, 1, 2, 3 spaces, right? 3 terms, I mean. If I have 3 terms, then I'm going to start 1, 2. I'm going to start writing right here. That's where I'm going to write. Okay, so first one. I want to match a 2. This doesn't have it. Well, then let's put it right here. Now, why did I write it on top of this one? Again, there's 3 terms, so 3 terms over. Here's my other reason. I'm supposed to have 4 x's. I only have 2. So I needed 2 more. See, my x squared should line up. That's why we started here as well. All right, let's multiply. 2 times that is just 2. X squared and x squared is x to the 4th. Perfect match. That's our goal. 2 times 3. Well, 2 times 3 is 6. X squared and x, there's the x to the 3rd. This is why lining up will remind you of what powers you need to bring in. And then 2x squared times 2. Well, 2 times 2 is 4. And I already know it has to be an x squared here. Look at that. Because of our lineup. So in case you forget about your powers, that's what's going to help us. And of course, I'm going to subtract. I'm going to subtract these values. Subtracting means I'm going to go in and I'm going to change every sign I see. So this becomes a minus. This becomes a minus. This becomes a minus. There, I distributed that negative. My 2x's to the fourth are gone, which is why we wanted a perfect match. 3 and negative 6 is negative 3. X to the third, continue that line up. 0 and negative 4 continues to be a negative 4x squared. And we bring down the 5x. Okay? It's all about matching. I want to match that x squared, but now I need a perfect match with this one right here. So I'm trying to match that negative 3. So if I'm trying to match that negative 3, well, then the first thing I need is a negative 3 because it doesn't have a number here. So I need a negative 3. Let me see. I do need one more x. Look at that. I need 3, but I have 2. So I do need one more. And besides, the lineup told me I was going to have an x there. All right, let's do multiplication. Negative 3x times x squared. Look at that. Perfect match, which is our goal. Negative 3 times positive 3 is negative 9. X times x is x squared. Besides, the lineup told me I was going to need that. And negative 3x times 2, negative 6x. Yes, look at that lineup. All right, let's start subtracting. Now, here's the other thing you may want to do. If you know you're going to subtract, it means you're just going to go through and change all the signs. So you can always just go right into it and go, let me change all the signs. If there was a positive, I would have changed it to a negative. So that's the other thing. Instead of writing it in parentheses, you could just go through and change all the signs. So, gone. Negative 4 and positive 9 is 5x squared. 5 plus 6 is 11 with an x. And finally, the last number comes down, which means this is my last step coming up. This is my last matching that I'm going to do. I want to turn x squared into 5x squared. Well, look, the x squared is already there. The only thing I need is that positive 5 because it has to be a perfect match. So let's bring in that positive 5 that I need. We write it up here. Look at that, no letters. 5 times x squared, perfect match, 5x squared. 5 times 3x, well, that's 15x. Remember, this doesn't matter if it matches or not. That doesn't matter. And 5 times 2, well, that's just a 10. We are going to subtract. Remember, you can just go through and change all the signs if you want. If you still like this idea of putting a negative in front, go for it. Feel free to do that. You just have to remember that you have to change all these signs. That's now a negative. That's now a negative. This is now a negative. That reminds us to change all the signs. All right, well, that was our last step. This is gone. Now let's see what our remainder is going to be. 11 and then negative 15 is negative 4x. Negative 1 and negative 10, negative 11. And yeah, don't worry that there's an x in it. This is my remainder. And we already talked about how we write our remainders. So I'm going to start off by writing my quotient up here. This is my answer. So my answer would be 2x squared minus 3x plus 5. And look, yeah, just put a plus sign. Always just put a plus sign there. Play it safe. And then here comes my remainder. Negative 4x minus 11. You just copy everything down. And underneath, we write whatever we were dividing by. For this problem, we were dividing by that. X squared plus 3x plus 2. Just like that, there's our answer. All right. So take a moment, of course, to write it down carefully. Again, you may want to pause the video as you go through so you can copy it. and then watch it again if you need to. But we had one more question. Here we go. Last one of the day. So number 4. Yeah, they're using the letter D. It doesn't change anything. It's just a variable. But I'm going to look at the biggest power. Power of 3. So let me do my countdown. 3, 2, 1. Power of 0. It's not missing anything. I don't need to bring in zeros. The biggest power here is 1. Power of 1, power of 0, perfect 2. I don't need to make any changes. Then let me start getting it ready for long division. 3D minus 2. And then, of course, I go 27d to the third plus 9d squared minus 3d minus 10. Always do a quick check. Make sure you copied everything accordingly there. You don't want to mess up on a power or anything. All right, it's time to match. Last problem where we match. My goal is to match this with this. That's my goal. All right. What do I multiply a 3 by to make it a 27? Or think of it this way. What's 27 divided by 3? You can see it in those two ways. So we already know 3 times 9, and I'm not writing it here because there's a 9. That's just a coincidence. 9 times 3, there's my 27. But look, I need 3 letter D's. I only have 1. That's why I know I wrote it here, because I need 2 letter D's. That's why I wrote it there, because I knew I needed 2 D's. So then that's D3. Look at that, perfect match. All right, but be careful. What's 9 times negative 2? Well, that's negative 18. And yes, there was a D squared involved. So D squared. Besides, your lineup helps remind you that there's a D squared. All right, let's do our subtraction, which means I'm going to change all my signs here. So I'm going with the negative, and then this one becomes positive. There's all my sign changing. So my 27s are going to cancel out right away. And if my 27s cancel out, let's see, this is gone. 9 and positive 18 is now a 27. 27 d squared, and I bring down that 3d. All right, now notice earlier we were trying to match a 3d with a 27d to the third. And look at this. We're going to try to match it again with a 27, but now with a d squared. So we kind of already have an idea what the number is. 3 times 9, right, was 27. So I need a positive 9. And we already know, look, we have 1d. I need 2 of them, so I needed 1 more. Here comes my multiplication. 9d times 3d, 27d squared. Look at that lineup. 9 times 2 is negative 18. And yeah, there was a d there. Anyways, it lined up for me. Here comes my subtraction. So that means I'm going to go through and change all my signs. Plus and a minus now. Okay, so let's see what we have left. Once I do my subtraction, they're gone. Negative 3 and positive 18, a 15d. And look, we know our last step is coming up because I finally brought down that last term. And my goal now is to match the 3d with the 15d. So let's see what happens here. 3 times 5. So 3 times 5 is going to give me that 15. And I already have the letter D, so I don't need another one. So it's just that. 5 times negative 2 is negative 10. Okay. We're going to do our subtraction here. Subtraction means that I'm going to change my signs. That's a negative, that's a positive now. So notice, my 15d minus 15d is gone. And when you look at this one, negative 10 and positive 10, also gone, leaving me with the remainder of 0, and that's okay. That just means I'm not going to write a fraction like I did earlier. My official answer is 9d squared plus 9d d plus 5. Just like that, no remainder this time. When there's no remainder, well, we just don't write a fraction at the end. I know the previous one over here had a remainder, so we wrote it as a fraction. No remainder, no fraction. All right, so dividing polynomials, it's just a process. You have to follow the process. Remember, matching using multiplication is the name of the game here. All right, with that said, you're going to try the problems on the other side. Have a wonderful day, everybody.